And what is special there is we said there was a sea of electrons. The electrons could just flow from one atom to the next, and that is why it can conduct electricity, and that is why it can conduct heat, and. Then next we had the covalent bond is between a non-metal and a non-metal mostly. And there was a sharing of electrons. So the electrons are shared in lock between the two atoms. It can't move anywhere, and that is why they cannot conduct electricity or heat. And then we had ionic bonds, and that is between a metal and a non-metal. And that is where we had a transfer of electrons, where the metal gives away and the non-metal takes. Does this ring a bell? There at the back of your head. All right. Then, so page 1 to 3 are grade 10 work that I'm revising. Okay. Next, the definition there for valence electrons. What is that? That is the electrons in the outer or the last energy level. Okay, so what is an energy level again? On the periodic table, we have our groups. Where's our groups again? Show it your hands.
What?
The groups. Here we have our groups, and here we have the periods. Alright, so when they say they're all electrons in the outer or the last energy level, it means in the outer or the last period. So if we look at the first example, there's sodium. Do we have sodium? Sodium is an energy level 3, the last electron. So it has 11 electrons. But the first 2 electrons are in energy level 1. The second is in energy level 2. And then we have 1 electron in energy level 3. So it has 1 valence electron. If we look at aluminium, its last electrons are in energy level 3. How many does it have there? 1, 2, 3 valence electrons. If we look at fluorine, there's fluorine. It's in energy level 2. How many electrons does it have there? 1, 2, 3, 4, 5, 6, 7. It has 7 valence electrons. Yes? Next thing there is the valency. So valence electrons. And then valency. Valency is the amount of electrons that an atom will accept, give off, or share to become like the closest noble gas. So here if we look at oxygen, oxygen can either lose 1, 2, 3, 4, 5, 6 electrons to become like a noble gas, or it can gain 1, 2 electrons to become like a noble gas. Which one is easier? Gain how much? 2. So that is why valency is negative 2, because electrons are negative. It gains 2 negative things, it's negative 2. Okay, if we look at magnesium here, magnesium will lose 1, 2 electrons, become like the closest noble gas. That's why it's a positive 2, because it lost 2 negative things. So it becomes positive. Yes? Alright. So valency there, the definition is the number of electrons that an atom will accept, give off, or share to obtain the electron structure of the nearest noble gas. Alright, and there I give you the examples of what they become. Here if you look at group 14, you see it's negative 4, positive 4, or positive 2. You can ignore the 2 for now. We're going to discuss that a bit later. Why is group 14 negative or positive 4? And I'm quickly going to show it here. Because group 14 can either 1, 2, 3, 4 gain 4, or it can lose 1, 2, 3, for it to become like a noble gas. So it can either gain or lose, it's halfway. Right. Then what we just discussed is the group. Now these are not definitions, these are just informal statements. The group, that goes down like this, that coincides with the valence electrons. How many valence electrons you have? And the period is the last energy level where you will find the valence electron. Okay, now your periodic table, sure. I'm just out of breath of speaking so much, will look like this. Okay, so you will get the numbers of the group as well as the Roman numbers. Okay, so let's quickly look at sulfur there. Sulfur is in group either 16 or group 6. So if you write normal letters, you're going to write 16. If you write Roman letters, you're going to write it 6 like that. Okay, 16 or 6, there's sulfur. So how many valence electrons does it have? 1, 2, 3, 4, 5, 6 valence electrons. Where will you find the valence electrons? In the third energy level. Yes? Okay. So, here it says, by using the rules above, we can identify phosphorus with having electron configuration of what? Okay, now to help us write down that, we're going to use the Aufbau diagram. Do you remember that?
Yes.
Or the energy level diagram. Do they sound like swear words again? Aufbau diagram. Not?
No.
You enjoyed it?
No.
Right, are you drawing the circles, Flornie? Remember, you can use circles or blocks or just lines. Doesn't matter, anyone. Because the sun is not shining on it. It's in the shade. Right, now phosphorus, if you look on the periodic table, is element number 15. So that means the neutral atom has 15 electrons. 1, 2, 3, 4. Then each one needs to have 1, 5, 6, 7 before it can have 2, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now I want to change this question a bit. I want to change it to, using the rules above, we're going to do it with having the, and then I want to change it to the valence electron configuration. The valence electron configuration. Valence means what again? The last or the outermost. So if we look here, the valence electron configuration looks just at the last energy level. Energy level 3. Then its electron configuration will be 3s, how many? 2, and then 3p, 3. As we're doing it, you should, in your head, you should be going like, oh yeah, oh yeah. Ne? Do you, yes, not? We have done all of this?
Yes.
Alrighty. Okay. So, let's say we did not have a periodic table. And I just give you that. Then I can ask you, in which period is this located? Do you think? What is the last energy level? It's energy level 3. So thus it is in period 3. And in which group will we find it? You look there. 2 plus 3 gives me 5. So you can either write it's in group 5 or you can say in group 15. Say again. 5, 6. Alright. He's counting in Spanish. Alright. Page 2. There I gave you a small periodic table that you'll always get in a test or an exam. I just quickly want to write down, first of all, the valencies of the groups. Just to recap, group 1 is +1, +2. Here we have +3, plus minus 4, -3, -2, -1, 0. Rings a bell?
Yes.
Then other ones that we use often is iron is +3, nickel is +2, copper is +2, zinc is +2. Nickel, yeah, it's +2. Copper can be +3, but most of the time it's +2. Silver is +1. Mercury is +1. Lead is +2. Those are the ones that we use most often. What? We will continue. I don't see you tomorrow.
Please.
No, I do see you tomorrow.